Lee Davies, thank you very much for joining me.
Pleasure.
Tell me about your work at Intel.
Okay, I work as part of the visual computing enabling team. So I'm based in the UK, near Birmingham. I work with the European team, which is part of a larger worldwide organisation that works with games developers, helping them optimise for both the Intel CPUs and graphics processors, and talk them through the various tools that we have available to them.
And I understand tomorrow you're going to be presenting on graphics performance analyzers.
That's correct. We have a tool called Graphics Performance Analyzers, or GPA for short. It's a tool that we've been working on for the last few years. It's on its third iteration now. You can download it free from the Intel Visual Computing website. You just need to go in and log in and register. That's all you need to do. The tool itself is a graphics front end that allows you to profile a DirectX game, whether it be DX9 or DX10. You can take some system diagnostics of everything that's going on the PC at that time, whether it's how busy the individual cores are, but also you can do a deep dive analysis of any individual frame. So you can do a capture. If you see a frame in your game that you think is typical of what you're trying to draw, you can take a capture of it, and the tool allows you to view all the individual draw calls that made up that frame. You can use it as an optimization tool where you can look at the most expensive draw calls, but the nice thing about it is it shows you how much screen real estate is affected by the individual calls. So it's all very well, if you find your most expensive draw call happens to be impacting 3 or 4 pixels in the top right, you know you're not getting bang for the buck. You might as well do that as simply as you can and use that time somewhere else. It allows you to do little experiments. You can turn individual calls off, you can change the textures, you can even rewrite the shaders and try something new. And so you can try and optimise and balance that game so it works as good as possible on the hardware you're targeting.
It sounds like it's also valuable as a debugging tool.
Yes, it can be. One of the nice things about it is if you take a screen grab and there is an issue on the screen, whether you're finding your shadows aren't quite working or you've got a model that you can see is wrong but you're not sure which one, you can actually take a screen grab, you can select an individual pixel on the screen where something's going wrong, and it will tell you all the draw calls that actually made up that image. And then you can look at each one, see all the textures that we used, the shaders, figure out where your problem was. The other nice thing about the tool is it actually does work across a whole range of platforms. It's not Intel specific. It will work with ATI and NVIDIA video cards. The benefit you get on an Intel graphics chipset, it actually allows access to the internal counters. So because it's Intel building that particular piece of hardware, we can expose information that we're not able to for a piece of competition's hardware. That means things that are internal to us, such as the texture bandwidth you're using, how expensive individual shaders are, we can actually show you what's actually going on under the hood. So for everyone's hardware, you get this overall thing that I mentioned earlier, where you can try and experiment on individual draw calls. If you're on Intel, it'll actually tell you just what's going on the hardware.
And how is it useful if you're part of a larger development team, for example?
One of the nice things is because it's actually showing you the whole system, whether it's the CPU or the GPU. A typical game, you'll have dozens of people writing the code, potentially dozens of artists all contributing to the final game. It's very hard to track what's taking the time, because everyone knows their own bit of code, but not many people know everything. The nice idea is just a snapshot of pretty much everything, so you can quickly visually see what's taking the time, and then make the decisions. The people, whether it's the producers or the actual technical artists or the lead programmers, they can get a very quick grab and go, that's what's taking the time, that's what we want, or hold on a second, let's step back. If you do this early enough, you've got plenty of time to then say, I've saved time, we can go away and improve it somewhere else.
Now there are other tools that Intel makes for performance optimization as well, aren't there, such as VTune?
Yes, there are other tools that we do. GPA is pretty much unique as it's very focused on the graphics and it's a free tool. But obviously Intel for a long time have had a lot of a track record of designing tools to get the most out of our hardware. Whether that's the VTune analysis tools that give you very deep diagnostics of the CPU itself, tools like the thread building blocks as ways to add parallelism into an engine, or the compiler, which has always been one of the leading tools for actual optimizations, especially on the newer Intel architectures, where we can expose things that maybe haven't actually propagated out to all the other compilers yet. It's a bleeding edge tool that we can use to get things into the industry. So there's a whole range.
That's great. Thank you very much for your time today, and enjoy the rest of the show.
Cheers.